Okay, we're going to finish the trig unit today and in the next video as well, and that's going to be on 122 today, and tomorrow will be on 123. We're going to talk about the law of cosines. Something that's nice about the law of cosines, remember the law of sines had an ambiguous case? The law of cosines does not, which really helps us out. It's just plug it in, solve it out, that kind of thing. So let's go ahead and label page 122. (14.2) Law of cosines. I'm going to go ahead and glue these both in. We actually will work on 122 and 123 today. We just won't finish the entire foldable. We'll do that in the next one. So go ahead and take this, the law of cosines. This is just the actual, it's blank right now, but this is the foldable. It's the one that tells you what the law of cosines is. So go ahead and fold that in. Not fold it, glue it in. If you have gotten a copy, you only need half of a piece of paper is what that is, so let's go ahead and glue that in. Okay, and then 123 is also law of cosines, so 14.2 law of cosines. 123. So this is, we're going to learn this over 2 days. We're actually going to do the notes all today. So I actually said in the second video, there's not a second video. It's going to be one video today. We're going to do 2 problems today on this foldable that we're going ahead and gluing in, and then we're going to do it. And if you wanted to wait and glue it in after, that's fine. But they go on 122 and 123. So we're going to do these 2 examples, and then tomorrow you're going to work on the work that goes along with this, and ask questions of me so that you're ready to take a quiz over this stuff, okay? So I've glued this one in here, and let's get started solving examples 8 and 9.
Different to memorize. But, and this is obviously not true, but this reminds me of another formula. It looks exactly like the Pythagorean theorem, except they just add on minus 2 times BC cosine of A. We're going to focus on this formula. So, when it's talking about it's saying a side length A, that side length squared is equal to the other 2 side lengths squared and added together, minus 2 times, again, the other side lengths, times the cosine of A, the opposite angle. We're only going to highlight that one. So while memorizing A squared equals B squared plus C squared minus 2BC cosine of A, I like to think of it as a side length. You have the side length and the angle are always at the beginning and the end. Then you have the other 2 sides squared and summed, minus 2 times the same number all over again. You're going to see what I mean by that in a minute. You can use the law of cosines when you know 3 sides, or a side, angle, and a side. There is no ambiguous case. So none of that we had yesterday. You are going to glue this in on 118. We did skip that page, remember, is it 118. We'll come back to that other page tomorrow. So glue this in on 118. Alright, so it starts at example 8 because it actually continued from yesterday's stuff. I found this all in the same place and I really liked it. So, alright, we have example 8, which says two sides and an included angle. We have side, angle, side. We are supposed to solve. It says draw a picture. We don't need to do that. We've already been given that. And solve for the missing information. So I'm going to look over here. The law of cosines is, I might have to close that window so you can see this. A squared equals b squared plus c squared minus 2bc cosine of a. Now, here's the problem, and you might want to use a different one. What is the only side length we don't have? B. So if you really need it to match, the actual one we're using this time is b squared equals a squared plus c squared minus 2ac cosine of b. I just have one of them memorized, and here's why. Because a doesn't have to be the actual a. It can just be I'm looking for that one. Okay? But we'll use this one so that that's not confusing there. So we're going to use this to find the missing side. Law of cosines I just plug in. Do I know B? Do I know A? What is it? Do I know C? What is it? Minus 2. We said A was 11. C was 14. Cosine. Do I know the angle B? What is it? Type all that in. The formula looks more complicated, but the work is not as complicated. It's really not that bad. Alright, before you round, what are we going to actually have to do to find B? Square root. So square root that number. 7 point what? Alright, and I'll let you round to 2 decimals. I'll let you round to 2 today. Alright, so that is B. Just like yesterday, we have to find every single missing piece. Before I slide this over, is anybody still looking at this? I don't want to ruin that for anybody. I have to find every single missing piece. What am I still missing? Angle A, angle C. I'm going to use the law of sines to find those. Yep. Yeah. Use the law of sines to find one of them, and then I use the triangle sum theorem to find the other one. So I don't have to do the law of sines twice. I only have to do it once. We're going to do the law of sines with A. Sadly, I have to use this 7.85. Why am I saying sadly? Because I hate it because we've rounded it a lot. So we probably should have done 4 decimal places, but we're not going to go back and do that. But we have to use this. We know B and its angle. Do you remember how we set up the law of sines if we know B and its angle? 7.85 over sine 34 equals, we are looking for the angle A. 11 over sine A. That's what we did some yesterday. Now, luckily, I don't have to figure out if I have more than one triangle because in side, angle, side, you only ever have one. Okay. How do we solve these again? So 11 sine of 34 equals 7.85 sine of A. Okay. Then what did you guys do? So sine of A equals 11 sine of 34 over 7.85. What do you do now? Inverse sine. Sine inverse. So A equals 52. And remember I said round those to the nearest degree. So that's good. 52. Alright, how about angle C? So 34 plus 52. So that's, is it 86, and then you subtract 180? So the measure of angle C is 90 what? 94. I heard 91 and I was like, no, it's not. Alright, there's how the law of cosines works. You normally have to use the law of sines too, which is why you learn it first. What? Yeah. Alright, however, when you have three sides, it's a little different. Alright, is anybody still looking at example 8 before we look at example 9? No. Okay. Alright, example 9. We have side, side, side now. We're going to use the law of cosines, but now we have to use the law of cosines to find the missing angle. You guys still have your highlighters out, I hope. Alright, this gives it to you step by step. First, it says use the law of cosines to find the missing angle opposite the longest side, B. Now, why in the world you have to do the longest one, I have no idea. You could do any of them first. But since it says B, we're going to use B. Which means we are going to use this because we are looking for B. The angle B. This is what we're looking for, is B. And I don't have enough room to do all this there, so I'm going to do it over to the side. And I'm going to plug in what I know. 27 squared equals 12 squared plus 20 squared minus 2 times 12 times 20 cosine of B. Yep. Yes, these always match. It would be B and B, A and A, C and C. Alright, I need you to have your highlighters because I need you to understand exactly what you need to plug in your calculator because we're going to have to solve. We need to know what 27 squared is. Okay. Then, you need to find out what 12 squared plus 20 squared is. Then, you need to find out what negative 2 times 12 times 20 is. I need to get cosine of B by itself. It's almost like your variable. It's your x, basically. This is a two-step equation. What do I need to do to get cosine of B by itself? subtract 544 first. It's like saying this is a number minus 480x. Subtract 544 first, which gives you then what? Divide by negative 480. We are not actually going to type that in. Wait a minute. That then means that cosine of b equals 185 over negative 480. How do I get b by itself? Inverse. That's what I need you to type in. What? 113. Okay, then we'll have to keep going. That's the law of cosine. What else do I have to find? Because I have to fill out this whole triangle. One more angle. The third one I can just find by subtracting. I have to use the law of sines to find that third missing angle, the next missing angle. Do you want to find A or C? A? Okay. I have to use what I know in the law of sines. What do I know? B. So 27 over sine 113 equals. You guys said we want to find A. Okay, so how do I set that up? Okay, so go ahead and start doing that. On your quiz, there's probably one law of cosine and law of sine out of I don't know how many. 12, 10, they're not many. Because I cannot imagine that you'll be asked that many ever anyway. Okay? There is no ambiguous case. We're going to talk about it in the homework, but it is not on your quiz. Okay, so you cross multiplied. 12 sine 113 equals 27 times sine of A. We've done this a lot. Divide by 27, right? And this is what you type in, but it's the sine inverse of sine A. So you're typing in the sine inverse to find what A is. What'd you get when you typed it in, somebody? 24. If it was 24 degrees, we might not be. I don't think we would do that. Okay. Alright, last but not least, I need you to find the measure of angle C. $23, 43, because I cannot hear, or subtract, evidently. 43 degrees. Fold that in half, glue it on 119. Same title. These examples specifically help, like they tell you, hey, you have two sides and an angle, do it this way. Hey, you have three sides and no angles, do it this way. That's what you need to be paying attention to today when you're doing your work.